Welcome. So in this video, we'll be answering this question before us. It says a hiker's distance from his campsite can be represented as a hybrid function where the horizontal axis represents the time in hours t starting from 6 a.m. and the vertical axis represents the distance d from the campsite in kilometers. Part A. If the hiker leaves the campsite at 6 a.m. and walks in a straight line at a constant speed of 6 kilometers per hour for 3 hours, how far from the campsite will he be? Okay, before we launch into this, let's begin by just drawing a graph of what we've been told. So here we are told that we have a horizontal axis which represents the time in hours, t, starting from 6 a.m. So if I'm just to draw this for a second, here's my horizontal axis, here's t, and we know that it's starting from 6 a.m. So what that means is when t is equal to 0 here, that's 6 a.m. We're also told that we have a vertical axis which represents the distance from the campsite. So it's the distance from the campsite. So this is d. Perfect. Now that we've got that, let's go on to part A here. So in part A, we're told that if the hiker leaves the campsite at 6 a.m., so that's when t is equal to 0, and walks in a straight line at a constant speed of 6 kilometers per hour for 3 hours, how far from the campsite will he be? Well, he's walking at a speed of 6 kilometers per hour. So that means once he's walked for 1 hour, he's gone 6 kilometers. Once he's walked for 2 hours, he's gone 12 kilometers. Once he's walked for 3 hours, he's walked 18 kilometers. And then we can even put this onto our graph like this. It's going to look like that. And that means our answer, so D, is going to be equal to 18 kilometers. And that's our answer. So we would say he will be 18 kilometers from the campsite, because remember what it's asking us. How far from the campsite will he be? He will be 18 kilometers from campsite. Without the graph, all you would have had to have done is gone 6 times 3, and that would have given you 18. And also realize that, it's distance equals speed times time. There's also another way to think about it, but all of that to say, we just had to write D is equal to 18 kilometers, because that's how far away he will be from the campsite. Perfect. Let's keep on going now. It says, find an expression for D in terms of t for this part of the journey. So to do this, we just have to write an expression for this, and it should be clear that this is just going to be 6t. So our answer will be d is equal to 6t, and that's it. D is equal to 6t because he's walking at 6 kilometers per hour. Perfect. Let's now go on to our next question. So we're told here, he then slows down and begins walking at a constant speed of 4 kilometers an hour. Find an expression of d in terms of t for this part of the journey. So I can already imagine what people are going to do incorrectly here. So let me tell you what I think that's going to be. They're going to look up here and say, well, for the last part, d was equal to 6 kilometers an hour. So we wrote d is equal to 6t. Well, if I'm now walking at 4 kilometers an hour, surely it's going to be d is equal to 4t. But that's not correct. That's not what my final answer is going to be. And to explore why that's the case, let's come up here. Let's grab our graph and let's have a look at this. So I'm just going to bring this down here. And let's just really visualize what's going on. So remember that if you are struggling with these type of things, you never just want to deal with things abstractly. You want to visualize it. So I am walking now for another part of this, and I'm walking at a slower speed. So that means it's going to be less steep. Going to be like this. And I now need to find an expression for this right here. So how am I going to do this? Well, I know that I'm walking at 4 kilometers an hour. So I'm correct in saying, it's d equals 4t, because that's simply going to be the gradient that I'm walking at, this 4 here. But what we need to be careful of here is the fact that, obviously that this line here, it's lifted up. It's not going through the origin. It's up here. So I need to figure out, if I were to extend this out, what would be my y-intercept? Because I've vertically shifted up. So I'm 4t plus some constant. Let's just call it c for the time being. So we need to find what this c is going to be. In order to find this unknown, we're going to have to sub in a point. Do I know a point that exists on this line? And I do. I know this point right here is going to be 318. That's where I'm starting from. So I'm going to sub in 318 to find c. So it's going to be 18 here equals 4, 3 plus c. 18 is going to be equal to 12 plus c. So that means I'm going to end up with 6 is equal to c. So my final answer is going to be D is equal to 4t plus 6. Let's put that in a red box because that is my final answer. So as I said, I think the main thing that people will get wrong here is forgetting to find that constant at the end. But don't be one of those people. Use your graph to help you think this through. So let's now also just put in that information here. This is 4t plus 6. Okay, let's keep on going. Part D. Let me get a highlighter. Okay, it says, he plans on returning to the campsite at 5 p.m. and he will walk at a constant speed of 6 kilometers per hour on the return leg. Show that he should begin his return journey at midday. So before we get into this part right here, let's just think through this return journey back to camp. And to do so, we are going to use the little graph that we've been generating, just to think it through. So let's grab this, let's bring it down. So let me get another color as well. So we're now returning back to camp. Oops. We're returning back to camp and we want to return back at 5 p.m. So that means when t is equal to 11. So I'm returning back to camp. I'm returning back at a speed of 6 kilometers per hour. So let's just draw this down like this. And the time that I should be returning back is at t is equal to 11. So we have a point, which is good, 11, 0. I now need to find an expression for this thing right here. So if I know that I am traveling at 6 kilometers per hour, what I could say is that d is going to be equal to, now this is important, negative 6t plus some constant. So remember, it's negative because I'm now going down. So it has to be a negative there. So I need to find what this constant is, and this is like the scenario I was in before. To do that, I'm going to have to sub in a point, and I have a point, this 11, 0. So sub in 11, 0 to find c. So to do that, I'm going to put 0 here. I'm going to put 11 in here. 0 is equal to negative 66 plus c. Therefore, c is equal to 66. So that means my equation that I'm dealing with is d is equal to negative 6t plus 66. Now, that's not what the question is actually asking us to do. It's great that we've found this out. We're going to need it. My t's are looking like pluses. But what we have to do is show that he should begin his return journey at midday. So we need to find out when he should begin his return journey. So we need to find this point right here. When should he begin his return journey? When should he turn around and start going back? Now, it's really important, and this kind of goes to the heart of these type of questions, is to turn this statement into something mathematical. And by looking at the graph, hopefully you can see that, hey, what we're trying to find is the intersection point of this and this. And if I can find that, I can tell you when he needs to start returning, what time he needs to begin to return. So I just need to find where these two things intersect. So I need to find where they intersect. That will tell me when he needs to start returning home. And to find when things intersect, I just make them equal each other. So what I'm going to do is I'm going to come over here and I'm going to keep my colors alive here. So I'm going to go, let me just break this up. I'm going to go 4t plus 6. And then I'm going to set that equal to negative 6t plus 66. So that's what I've got. Now I'm going to solve this. Let me just get black out. So I'm going to plus 6t to both sides. That will give me plus 10t over here, or minus 6 from both sides, which will give me 60 here, which means t has to be equal to, well, 60 divided by 10 is 6. Now, what is t is equal to 6? Well, if I'm starting from 6 a.m., 6 a.m. plus 6 is 12. So it's midday. So how could I put this as eloquently as possible? I could say 6 hours after 6 a.m. is midday. And that would be my proof, or my ending statement there. So this right here. So 6 hours after 6 a.m. is midday, which proves that he needs to make sure that he, starts heading back to the campsite at t is equal to 6, or in other words, midday, to make sure he's back by 5 p.m. So this was 6. Perfect. Okay, let's keep on going. This is a long question. He goes, what will be his distance from the campsite at this point? So what will be his distance from the camp point at this point right here it's referring to? So if I know, and let me change my colors. If I know that I'm dealing with d is equal to negative 6t plus 66, and he starts heading back at 6 p.m., I'm going to sub in t is equal to 6, which is going to give me d is equal to negative 6 plus 66. And then, if we keep on going, we're going to get d is equal to negative 36 plus 66, which means d is going to be equal to 30. So therefore, 30 kilometers. That's going to be my answer. Perfect. Now we come to the last thing we have to do here, and we've actually been doing this throughout this whole thing, and that is sketch a hybrid function including all key points. So we've been doing this kind of just messily, just to help us understand what's going on. And now it just wants us to do it formally. So let's keep all our colors alive here. So remember, for the first portion of this, we were going up 6 kilometers an hour. So 1, 6, 2, 12, 3, 18. Oh, now, there's no way I'm going to be able to draw a straight line through these. You know what? That was pretty good. And we know that this point right here is going to be 3, 18. And then we know for the next leg of this thing, and let me put in d is equal to 6t here, just for the fun of it. And now we know that the next part, I'm going 4 kilometers an hour. So that means when I'm going 18 plus 4 is 22. It's going to be about there. And then I'm going to go 22 plus 4 is 26. So that's at 5. And then 6 will be 30. So that's what it should look like there. This is what my point should be. Let's see if I can draw this nicely. I'm just killing it with these lines. 6:30. And then I'm going all the way down. So remember, we did this in brown. And as I'm going all the way down, I need to get to t is equal to 11. So let's see if I can do this. There's probably no way I'm going to be able. If you had a ruler, you could do this perfectly, because you're just going to put 1 here and just go all the way down. Let's try that again. Let's try it one more time. Let's all pretend that that's a straight line. So this is going to be -6, so d is equal to d is equal to -6t plus 66. And then I also need to put in what that other line was, which was d is equal to 40 plus 6. Perfect. And that's all good. You know what I want to put as well? I would want to put in this as being 11, 0. I might even want to put this as being 0, 0. I've got that, including all key points. I think that's pretty good. Hopefully you found this video useful and just found it, this question isn't as bad as it may first appear. Okay, so with all that being said, hopefully you found this useful, and I will see you in the next one. Bye-bye.